Hello, my friend. I hope you are doing well. And today I want to solve for you one of the problems related to first International Mathematical Olympiad. It is a simple one, but it would be interesting for you also for me. So we want to prove that this fraction is irreducible. So before solving this question, let me introduce for you and explain what does it mean when we say that one fraction is irreducible. So let's suppose we have a one fraction, like for example, 21 over 14. So we can rewrite the numerator by 3 times 7 and denominator by 2 times 7, and you can cancel it 7 and 7. So you can write that which is equal to 3 over 2. So you can see that here you cannot continue your cancellation, and it is a simple form, the simplest form we can have it. So, and if you compare with this fraction, okay, and make a connection between the concept of the greatest common divisors of two numbers. So let me find the greatest common divisor of this fraction. I mean GCD. GCD is a Stanford of the greatest common divisor. So 21 and 14, so which is equal to actually 7. So that's why the fraction in the left-hand side, it is not reducible. See, we can say that it is reducible, but in the right-hand side, the GCD of 3 and 2, which is equal to 1. That's why we can say that they are co-prime 3 and 2, and also this fraction is irreducible. So when we say that one fraction is irreducible, it means the GCD of numerator and denominator of that, which is equal to 1. Okay? So, hey, let me summarize my talking. So it means if I denoted this fraction by a over b, I mean numerator which is equal to a and denominator which is equal to b, we want to prove that GCD of AB, which is equal to 1. Let's do it together. Okay. So right now we want to prove this claim. I mean, the GCD of AB is equal to 1, where A, which is equal to 21 times n plus 4, and B, which is equal to 14 times n plus 3. So the key idea for solving such this problem, I mean, when we want to prove that two positive integer are co-prime, the key idea is, first of all, we consider that actually the GCD of two positive integer number a and b, which is equal to d, then we need to prove that d divides 1. Okay, that's it. So because you know that any 1 divides any integer number, so based on the rules of divisibility of integer numbers, we can claim that at the end d which is equal to 1. So let's do it together. So let's prove it. So we know that d, we suppose that d is the greatest common divisor of a and b. So it means d divides A. I mean 21 times n plus 4. Also, D it should be, because it's also a divisor of B, should be divides 14n plus 3. So right now, based on rule of divisibility, we need to cancel the parameter of, the coefficient of n. So how we can do it, and let me remind you some rule in the left hand side. I will pause the video because I want to save your time. So right now we need to use this rule. A divides B, so we can multiply right hand side by one integer number like n. So if I do here, let me raise here, and we have parentheses in the left hand side. So first of all, I multiply by 2, the right hand side. So I have D divides 42 n plus 8, and the last one we multiply by 3, so we see by D. Okay, and D divides 42 times n plus 9. So far so good. And let me again remind you another property of divisibility. Okay, right now based on property 2, if I write this guy, in this way, D divides 42 times n plus 8 plus 1. Okay, and right now I can claim that here, and this guy is a B, this guy is a C, and D is a A. So based on property 2, I can claim that then D divides 1. So right now we prove this guy, but let's come back to our question. Our question said that all positive integer numbers. So it means this guy is a integer number. A is an integer number. The natural number. Also B is a natural number. So we have another properties. Let me write for you in the next slide. So based on property 3, A divides B and B divides B. If we have this condition, then we can conclude this implies that absolute value of A is equal to absolute value of B. So, but if both of them are positive integer number, they are natural numbers, so we can say that A is equal to B. Also, we know that 1 divides any integer number. So, based on this and property 3, we can conclude that D which is equal to 1. Okay, we prove that this guy. So let's come back to our question. So we proved that GCD of A and B is equal to 1. So it means we prove that GCD of A and B, which is equal to 1, they are co-prime. So it means actually this fraction is irreducible. So it's irreducible. And the proof is. Thanks for watching this video. See you next time.